Welcome to this tutorial on 1D optimization and miter cuts in TonCut. Today, we'll walk through how 1D optimization works, how to use miter cuts effectively, and how these settings impact your results. Let's get started. 1D optimization in TonCut is similar to 2D optimization. You still need to enter pieces, stock items, and a material group. The main difference is that in 1D optimization, we're optimizing only along the length. When entering pieces, you only need to input their lengths. For example, here we have lengths of 870, 1100, 540, and 300 millimeters. As you can see, these pieces require specific cutting angles. We'll discuss this in more detail shortly. Next, we'll need a stock item. In this example, we're using a single stock item with a length of 6 meters. For now, we'll set the edging value to 0, though you can adjust it as needed. We already have the material group, but make sure it is set to the 1D type. It's also crucial to assign the correct 1D cutting device. Otherwise, you might encounter issues with miter cuts. The rest of the material group settings are covered in another video, so let's just move forward. With the pieces, stock item, and material group in place, we can start the optimization. The optimization will take a moment to complete, and once it's finished, the results will be displayed, showing the most efficient way to cut the stock. We have the results, and as you can see, they are quite well packed. The optimized layout uses miter cuts to group elements with similar angles close together, minimizing waste as much as possible. The results are efficient and well organized. Okay, let's talk about miter cuts. To optimize with miter cuts, your 1D device must be configured in the library, and the miter cuts option must be enabled. This setting tells TonCut that your cutting device supports miter cuts. If this option is disabled, the optimizer will default to perpendicular cuts only. By default, miter cut angles are calculated as follows. For the left side, the angle is measured from the center to the right. For the right side, the angle is measured from the center to the left. A 0-degree angle results in a perpendicular cut. If your cutting device has different requirements, you can adjust these settings accordingly. For devices with 2 blades, you may need different settings for each side. For single-blade devices, you'll typically use the same settings for both sides. It's important to note that these settings are specific to your cutting device and don't need to match the values entered in TonCut's interface. When printing results, TonCut will display the required angles for your device, ensuring proper alignment. Since devices may have different miter cut settings, TonCut makes it easier by allowing you to configure a single way for entering and displaying angles in the user interface. To change this, go to the Options menu, navigate to the Configuration section, and select the Dimensions tab. Here you can define how angles are handled. By default, on the left side, angles are measured from the center to the right, and on the right side, they are measured from the center to the left. Simply choose the option that suits you best, and TonCut will automatically recalculate the angles to match your device settings. As you've already seen, our pieces have some cutting angles defined. Since we're using the default miter cut settings, we can enter positive, negative, or 0-degree angles. An angle of 0 gives you a perpendicular cut. Changing the left angle to 20 degrees results in such a cut. Now let's set it back to minus 17 degrees, and now you can see how it works. Simple, isn't it? It's important to remember that when using miter cuts, the specified piece length includes the slanted ends. And one more thing to keep in mind. If you disable miter cuts in the device settings and rerun the optimization, you'll notice significantly more waste. This happens because the optimizer treats all pieces as simple rectangles. To improve efficiency, ensure miter cuts are enabled in your device settings. All the optimization options here work in a very similar way for both 1D and 2D materials. But it is worth to mention that for 1D optimization, selecting the shortest production time criterion prioritizes grouping pieces of the same size together. You can see it here. This arrangement speeds up the cutting process by reducing the need for adjustments, even if it results in slightly more waste. While material optimization is still taken into account, it has a lower priority compared to minimizing production time. Now, let's look at the optimization results. While not all pieces are grouped together perfectly, the waste is significantly reduced, and most pieces of the same size are still placed together. TonCut evaluates multiple factors to determine the best solution. In this case, it decided that this solution is better, even though not all the pieces are grouped closely, because the waste is significantly smaller. Now, let's revisit the material group settings and disable rotation and reversal. This significantly limits the optimizer's flexibility, making the process more challenging. Let's switch the best solution criterion to smallest waste and rerun the optimization. As you can see, without rotation and reversal, the optimizer struggles to adjust pieces efficiently. Although miter cuts are still used, the results are less optimal. Okay, let's take a look at the results. Despite the limitations, TonCut managed to find a solution using 3 stock items, which is actually a pretty good outcome. While there's some interlacing of pieces, the results are better than expected. That concludes this tutorial on 1D optimization in TonCut. I hope you found it helpful and informative. Thanks for watching, and see you in the next video.